Okay, Module 2, Lesson 2, Writing Algebraic Expressions. So now we're going to get into what algebraic expressions are and all that. The first learning goal for today is create algebraic expressions. How you'll know you've got this lesson down is you can read an expression with comprehension, meaning you understand it. You recognize coefficients, factors, terms, and constants, so what they are, what they do, and all that. You understand that an expression is a statement that describes a relationship between data. You can write algebraic expressions given a verbal description, and you can write verbal descriptions given algebraic expressions. The vocabulary for this, the first word, expression. So an expression is when you have numbers, symbols, and operators. Operators are just like the addition, multiplication, what you do between numbers, grouped together that show the value of something. So for example, 3 minus x over 2, that's showing the relationship between whatever's in here, and it's describing something else. Or 4 times x to the second power, that's what we're going to talk about is a term, and then plus this other term 15, that makes an expression altogether. So a term is either a single number or variable, or numbers and variables multiplied together, and they're separated from each other by plus or minus signs. So 4x, that's just 4 multiplied by x, that together forms just one term. Then 2 times b to the second power, which is 2 times b times b, that is its own term. That's just one term altogether. And -5 times x times y to the 5th times z to the 7th, all together, because all those are being multiplied, that forms just one term. A constant is just a number that has a known value, like there's no variable, it's just that number, and it stands on its own. So 15, we know the value of it, and it stands alone. It's not multiplied by another variable or anything. And -2, it's a negative number, but again, it stands on its own. We know the value of it, so it's a constant. So a constant can be positives or negatives. So like terms are terms whose variables, such as x or y, with any exponents, such as the 2 and x squared, should be squared, are the same. So like -12 times x times y, those variables are the same as over here, 5 times x times y. So since the variables are the same in both terms, we say they're like terms. And factors, these are numbers we can multiply together to get another number. So 2 and 3 are factors of 6, because 2 multiplied by a number, here 3, is equal to 6, and 3 multiplied by a number, here it's 2, equals 6. Like for another example, if you wanted to find factors of 12, you can have 2 and 6 are factors of 12, and 4 and 3 are factors of 12, and 1 is always a factor of any number, so 1 and 12 are factors of 12. What factors are. Coefficients are a number used to multiply a variable. They're placed in the front of the variable in an expression. In the term 4z, that number in the front, 4, is a coefficient. The thing that I need to emphasize here is a coefficient is always just the number. You don't say a coefficient is the entire term. It's just the number in front of the variable or variables. So here it is just 4. You do not include the z when you report the coefficient. Okay, so the concepts for today are the language of algebra. So algebra is the language of mathematics. You learn any new language, you learn the terms and how to put them together into sentences and paragraphs. So in this case, it would be like putting those terms together to form expressions. We'll be learning how to put them together, like the terms together, and evaluate and simplify them. So that's going to come later on in the week. Just like the basic vocabulary in any language, these are necessary to begin to understand the use of algebra. So variables, you need to understand what variables are and what they do. A variable is a symbol or letter used to stand in for a number. So they just hold that place for whatever number they represent. For example, if you are told that the way to find the area of a rectangle is L times W, or length times width, that's why we have L standing in for length and W standing in for width. We don't know what numbers we have for whatever we're measuring, so we just put those numbers in there and we can replace them with whatever we measure to be the length or the width. Algebraic expression. So in mathematics, an expression is a type of mathematical phrase. So it's like a sentence. It can contain numbers, operations, variables, or any combination of those. An algebraic expression consists of one or more numbers and variables along with one or more arithmetic operations. Some examples could be like 6x, that's the number 6 multiplied by the variable x. So that together there is one or more, it's called numbers or variables, and one or more arithmetic operators, which like the multiplication. Here, 5 minus 2x, that together is an expression. We have the term 5 and then the term negative 2x. 3 over x minus 2y. So here we have 3 divided by x, and we're subtracting 2y from that. And here it's just one term, but there's multiple things going on. So 6 times n to the third. So n is being cubed, that's one operation, and then it's being multiplied by 6. So there's two operations here in this expression. So a term is a number, variable, product, or quotient of a number or variable. Each of the following expressions is a term. So by itself, it's a term. Notice that there are no addition or subtraction symbols within the term. A numeric term is called a constant. So here, this term, because it's just a number standing on its own, we say that is a constant. This is just a variable term. It's just standing in for whatever number it represents. This, we have 3 multiplied by the variable y. So here we have the coefficient 3 and the variable y being multiplied. And the number 5 multiplied by x to the second power times y. So we have two variable terms and the coefficient. And then 3m divided by 2, so 3, the coefficient to m. These are being multiplied, and then that's being divided by 2. That is a term. So the terms of an expression are always represented by addition and or separated by addition and or subtraction symbols. The addition or subtraction symbol before the term is considered part of the term. So here, if you look at this example, you have 4x squared, that's a term, and then negative 3 over here, because we use the signs in front of them, this term is negative 3, right? We can't just say it's 3 and it's being subtracted. When we list terms, we always use a sign in front of them. And if there's no sign in front, we say it's positive. So here, this is positive 2x, and this is negative 5x. So like terms are terms that have the same variables and the same exponents. The terms in the same colors below are like terms. So here, the 2 in green, they're x squared terms. So we have 4x squareds here and 3x squareds here. Together, that would make 7x squareds. Here we have 2 x's here and negative 5 here. So you could combine those to get negative 3 of them, negative 3 x's. And then the constants can be combined too. So we have positive 4, just the number, and then negative 3, just the number. So all together, you could get just 1 if you combine those. Terms listed below are unlike terms, so they have different variables, but the power and the powers of exponents can be different. So either way, they could either have different variables or different exponents to those variables. Any change that makes them not look exactly the same is going to mean they're not like terms, they can't be combined. So here we have 4x squared and 2x's. Those cannot be combined because the exponents are different in that case. And that has nothing to do with their coefficients. The coefficients just tell you how many you have in that group. So here we have 4x squared, and here we have 2x's. So if these had the same exponent, then we would be able to combine those numbers, but we're not using the coefficients to tell us whether they're like terms or not. Coefficients have nothing to do with telling if they're like terms or not. So here we have this expression, and it's asking us how many terms are in the expression. So we'd say 8x is one, 5y is another one, negative 3z, positive 17x squared, and negative 24. Those are our terms. I'm listing the terms, and that means we're just going to count the ones separated by positives and negatives, or plus and minus signs. 1, 2, 3, 4, 5 terms. So the constants here are the numbers that stand on their own. They're usually at the end of expressions. And over here, that means we have negative 24 as the constants. So when we're writing expressions, we need to know what vocab is going to signal us to commit to an operation. For example, with addition, we commonly see the words sum, total, plus, increase by, and more than. So those are going to tell us that we are going to use the operation of addition in our problem. For subtraction, we commonly see difference, minus, decreased by, less than, and subtracted from to tell us that we are going to subtract numbers from each other. For multiplication, we commonly see times, product, right? When the result of multiplication is a product of, like groups of some number, and then we know that we have to like put those all together. Twice, multiplying by 2, double, again multiplying by 2, or triple, multiplying by 3. Those are commonly used to signal multiplication. For division, we see a lot of like quotient, the result of division, separate into groups. We know we have to divide, divided by, and half or a third, right? Divided by 2, divided by 3, the signal that we are going to divide something. Parenthesis phrases, so whenever you have like an operation onto another operation, such as like times the sum of, or times the quantity resulting from blah, blah, blah. So it's an operation on another operation. That means you have to use parentheses on what is the second operation. So here, times the difference of or between, you would use those parentheses on what is in quotation marks here. Turnaround phrases such as like less than or subtracted from, or even more than, those tell you that whatever you're taking less than of, it's going to go at the end. So if it is like 8 less than 2 times x, you're going to write 2x minus 8. That subtracting 8 goes at the end of the problem, or the end of the expression. And these are just the signs or the the symbols that we use to represent like less than or equal to. So comparisons between numbers, they're called inequalities. And writing algebraic expressions, going from words to symbols. So for here, we're going to write an algebraic expression that represents 8 more than a number. So we have 8 more than a number. So let's decode this. So first it said, like spelled out 8. And now I can write that as the number 8 here. And then it says the number. So I'm going to use, I can use whatever to represent this number, but let's use n here. Right, number starts with n. Then, so this is my variable, right? It's standing in for, I don't know what number they're asking me to find 8 more than, so I'm going to use n to represent that. And more than, this part signals addition, but it's also a turnaround phrase, right? It's a turnaround phrase of addition. That means I'm going to start with what's at the end, so n, and I'm going to add, right? It's addition, and add 8 to it. So this is the expression 8 more than a number. Next one, write an algebraic expression that represents the product of 2 and m plus 4. So product of 2 and m plus 4. So again, decoding this, I'd say product means I'm going to put a little asterisk for multiply. Multiply number 2 and m. So this is my variable. I'm just going to leave it as m. And here I know this 4 I can represent as a number 4, and plus is addition. Okay. So now I kind of like wrote the symbols and the numbers that represent whatever this is talking about. But it's asking me the product of 2 and m. So product of 2 and m, that means I'm multiplying 2 and m. The way I can write that here is just 2 and m right next to each other, because that implies they're being multiplied. And the next part is just plus 4. I know that's addition. And I'm at plus 4. That's it. There's my product of 2 and m plus 4. Next, write an algebraic expression that represents 3 less. So 3 less than the quotient of a and 8. Again, I'm going to decode this, so this I can write as the number 8. A is going to stay the same. Quotient, we said, is division, and 3 less. So this is 3, and this one, less than, say it's subtraction, less than is subtraction, and it's a turnaround phrase. So I know that's going to go at the end. That 3 less than is going to be at the end, subtracting 3 at the end. So 3 less than, and the quotient of a and 8 is going to go at the beginning. And I know that quotient means dividing. So I'm going to just put like a fraction line that means dividing. And whatever comes first is the numerator, and whatever's second is the denominator. So a over 8 minus 3. A divided by 8 minus 3. Next one, example 5, write an algebraic expression that represents the quantity. So this is going to really help us. Oh, quantity of 6 minus x divided by 2. Again, this one I can write as the number 6. This one is 2. This I keep as x. I know minus is subtraction. And I know divided is like division. But since it's saying the quantity of 6 minus x, I know if I want to find the quantity and do something to that quantity, I have to put that operation that's going to give me that quantity in parentheses. So 6 minus x. Quantity of 6 minus x is just what's in these parentheses. This is the quantity. And that is going to be divided by 2. So I could either write it divided by 2 like this, or 6 minus x in parentheses over 2. So I think it's in the slides too, right? So it's either way is correct. You just need to write that like 6 minus x in the parentheses. So it can all be divided by 2. So then write an algebraic expression that represents 9 minus the difference of 5 and y. So here, this is number 9, this is 5 minus the subtraction. Difference is also subtraction. And y, I'm just going to leave it like that. So 9 minus, remember 9 minus, and that's not a turnaround phrase, so we're going to keep it in the front. 9 minus the difference. So this is an operation subtraction on another operation, another subtraction. So 9 minus the difference is going to go in those parentheses. So I have to find the difference of those two numbers before I can subtract them from 9. So it says the difference, so I'm subtracting in there, and I have 5 and y. So this would be that 9 minus the difference of 5 and y. Okay, so that is going from words to symbols. Next, we're going to work on going from symbols to words. So there's multiple ways you could do this. As long as it works, it doesn't necessarily need to be like everyone's going to say this the same way. For example, I have like an x variable here. I have the 3 as the exponent. I have a plus sign and 4. So there's multiple ways I can do this. And say x cubed, right? We're cubing x plus 4, right? I'm adding 4. That's one way I could say it. I can also say x to the 3rd power plus 4. That's another. And we can say the total of x cubed and 4. My favorite is the sum of x cubed and 4. The sum tells you you're going to add, right? Sum tells you they want the result of addition. So here, they just do the same things.